Cutting it in 3, 2, 1. Hello Year 11s, I hope you're all doing well. What I'm going to do in this video is I'm going to go through the first section in the Mathematics Extension 1 booklet. What we're looking at today is looking at the relationship between roots and products. So what we're looking here is we're going to look at the relationship between the coefficients of a quadratic function and the roots of a quadratic function. So this first video is just going to go through the notes. You might not like reading, so I'm just going to go through it and hopefully help you out. Just explaining what the content is about. So let's get started. This first section, we're looking at polynomials, and we want to establish a relationship between the coefficients of our polynomial and the roots. So the roots or your zeros are just your if you remember, where if we sub in the value into x, it'll give us a value of 0. So that's what we're doing in this next section here. So what we want to do is establish that relationship between the two. And you might not think there is immediately obvious relationship, but there is this nice little pattern that we'll eventually notice that we get when we play with the roots and the coefficients. So let's have a look. Here's the setup that we have. Let P of x be a quadratic, and this is in the orange box we have what that quadratic is. So we've got P of x is equal to ax squared plus bx plus c. And it has two roots, so we're defining the two roots as alpha and beta. So what we have is the two values that when we sub it into my x, that will give 0 for this polynomial alpha and beta. Now, using this information, we can actually write the P of x as in a different form. If you notice, our polynomial has a leading coefficient of a. So when I write my polynomial, I'm still going to need to have a out the front, because I need to have that a multiplying into my quadratic for the whole thing. So I can rewrite it as a times x minus alpha and x minus beta. Now, this is what we did last lesson with our when we were looking at factor theorem. If we know that a number is a root and it gives me 0, it tells me that. So if P of alpha is equal to 0, that tells me if and only if x minus alpha is a root. So this is the opposite fact. So we're using the fact that alpha is a root. So alpha is a factor, I mean. So we're using the fact that alpha is a 0, which is what we have up the top here. Yeah, I had it right the first time. And we're using that to establish the fact that x minus alpha is a factor. Now we know that alpha and beta are the two factors, so I can actually write my polynomial as these two factors here. X minus alpha and x minus beta. Now from this, what we'll notice is that actually for our polynomial, this is the exact same polynomial. We have two forms that we've written our polynomial in. These two forms. The two in the orange boxes. So what we can do is we can actually equate the two and equate the coefficients in two, and we'll see that there's actually a nice neat pattern. Now in the notes, I've expanded out this second box for you already. So in the notes, it tells us that this is equal to alpha times x squared minus it's a times x squared, a bracket, alpha plus beta x plus alpha beta. So this is what when I expand out my polynomial that's in the brackets, this is what it gets me here, this thing here. Now if you notice, we can actually compare the coefficients of so I'm going to do this in a green pen. I can compare the coefficient of my x squared term. I can compare the two, and they should match up. They should match up. I can compare the coefficient of my x term. So over here, let me highlight it in color yellow. I can match up my coefficient of my x terms, and they should also match up. And the final thing is I can also match up the coefficient of my last term here, my constant term, and they should match up. And as a result, we actually get this fact. So if I have a polynomial p of x with the conditions that that I have up here, I have these special relationships that I will write down here. So if I've got alpha plus beta, so that's this middle term for my x coefficient. If you have a look, I've got negative a times alpha plus beta is equal to b up the top here. So if I rearrange this a bit, I get alpha plus beta is equal to negative b over a. Oh, and I'll write this in color. It's negative b over a. Now this relationship, as you can tell on the left-hand side, we're adding the two roots. So this is the sum of the roots, or sum of zeros. So when I add my zeros, what I'll get is the coefficient of my x term divided by the coefficient of my x squared term. Now, if we have a look at the if we have a look at the constant term, I realize in my constant term I'm missing an a here. What we have is a very similar relationship. So here, instead of it being the sum of my zeros, I'm going to have alpha beta. So that's the product is equal to c over a. So this is my product of roots. Product of zeros. In the next section of the Extension 1 course, we're actually going to be working with these two relationships. And in particular, we're going to be manipulating this stuff on the left-hand side and using these two facts and the relationships that they give us in order to help us establish a few relationships here. It will also help us to find the roots of a polynomial when we are when we have a few of them already given to us. It will help us try to find it'll help us to establish a few algebraic relationships and identities as well. So that's what we're going to be doing with these roots and products relationships, roots and coefficient relationships. So the main thing to take away is if we have a quadratic, we can actually establish a relationship between the roots, alpha and beta, with the coefficients of the terms in my quadratic. What I'm going to do now is I'm going to go through a couple of questions that will help us work with these two relationships.